Hello, let's go. Advent of Code, day 3. That's the question. The time wise, it's 7:15 ish. Let's, yeah, probably I will still be able to solve part one, but let's, like 45, it should be the max. Then at 7:45, I should stop. It's a bit like, should I just maybe something like start a counter for half an hour. Okay, let's go. Okay, by the way, who am I? What am I doing? I'm a software engineer. I like coding in the evenings as well. I don't know the reason, but I like it. And I like creating content. That's why I'm streaming. And here I am solving Advent of Code. You can imagine this is like a puzzle, but they're not easily solvable with pen and paper. You have some kind of computing source. It can be a calculator or something else, but ideally it can be a code that you can run to solve them. There are like various metrics that you can, if you like, think about, like optimizations regarding speed of the program, like and also how much resources that it uses. We can call it like that. But basically, I'll try to reach to an answer. This is not the solution video. I've never seen the video question until now. Well, let's see. And sometimes I can't solve the question, which happens. You descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint when you get to the main elevators. However, you discover that each one has a red light above it. They're all offline. Alright. Sorry about that. An elf apologizes as she tinkers with a nearby control panel. Some kind of electrical surge seems to have fried them. I'll try to get them online soon. You explain your need to get further underground. Oh, you're going underground, right? Um, well, you could at least take the escalator down to the printing department. Not that you'd get much further than that without the elevators working. That is, you could if the elevators were offline, right? But don't worry, it's not fried. It just needs power. Maybe you can get it running while I keep working on the elevators. Let's go. There are batteries nearby that can supply emergency power to the escalator for just such an occasion. The batteries are each labeled with their voltage. What are we talking about? What is that? What does this even link goes through? Day 10? Wait, what? Oh, 2020. All right. Okay. The batteries are each labeled with their voltage rating, a value from 1 to 9. You make a note of their voltage ratings. Your puzzle input, for example, 9, 7, 9, 8, 7, 6, 5, 4, 3, 2, 1, 1, 1, 1, 1, 1, 1, 1, 8, 1, 1, 1, 1, 1, 1, 1, 1, 9. Anyways, so there's like how many batteries? So there's like this much batteries there. It's like 20 or 20 batteries on each line. I guess so. Okay, the batteries are each labeled with their voltage rating, a value from 1 to 9. Alright, the batteries are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries, all right, a group of batteries. Within each bank, you need to turn on exactly 2 batteries. The voltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. For example, if you have a bank like 1, 2, 3, 4, 5, and you turn on the batteries 3 and 4, the bank would produce 24 joules. You cannot rearrange the batteries. You need to find the largest possible voltage each bank can produce. In the above example, in here, you can make the largest voltage possible, 98, by turning on the first 2 batteries. In here, you can make the largest voltage possible by turning on the batteries labeled 8 and 9. Here, you can make 7 and 8. The total voltage is the sum of the maximum voltage from each bank. Your basic is summing them up. There are many batteries in front of you. Find the maximum voltage possible from each bank. What is the total output voltage? Let's go. Get your puzzle input. What the? Well. No, not here. Q3. Let's say part 1 pi. And also input txt. All right. And then input txt will have them. Okay. So how many is it? 100 selected. So I guess, right? So column. So this is 100, and this is. Wait, this is 1, 2. Okay. So there is like 100 on each line. So how many we have? 100 times 200. It's not 20,000 batteries here, but 200 banks we have, and in each bank we have 100 batteries, right? Let's start with processing the input. With open input.txt, read mode, but I don't need to specify it. Encoding and stuff, I think I don't need to do anything. We can open it like this. We can then I don't know, like some kind of this, read lines. Let's see how it, I'm assuming it's a list, but it's like properly clean one, right? I think I have to specify this. So, okay, it's not clean as I would have guessed. So you have this last thing. Is it something that you can do? I don't know. Maybe we can do more proper one, like what was this like? What was the ideal way of doing it? I think like read at most size characters. Read from underlying buffer until we have size characters, or we hit end of the file. No, not that one. Read line. Read until new line, or end of. Return an empty string. So you can say bank. Let's print bank, for example. So it's I think it's a proper one. We can call it banks, all right? And we can append this thing until it returns empty string, right? That's then here. Let's print banks. Of course, it has to be while true, right? It has to do it in a loop, and then if it doesn't, we'll just break it. All right, so I think we are going good, but except these things, you can basically yeah, what's the best way of cleaning? Is it like strip? But I think strip does it for white spaces. Oh, okay, it does it for. All right. Yeah, it handles that apparently. It's good. So we have the data, right? We have the banks. I would just like to make it modular. I would like to call it get banks, and it will not accept anything. It will just return what we want. Return banks. So when we call get banks, it will return what we want. Okay, as you see, I'm trying to get incremental approaches, small steps to small steps. So once we have the banks, we can let's store them here, and then we're going to calculate each bank's a value. What's the value that we jolted, right? We want to have the max jolted value from each bank. All right, so that's why I'm calling like get max joltage, or like you can calculate max joltage. Let's call it calculate. All right, there has to be some kind of logic there, so I want to call it calculate. Max joltage. By the way, I can do a type hints here, just for the sake of I don't know. You know, IDs also like highlight something, so it could be nice to do it. Calculate max voltage will have basically a string, and it will return an integer, right? Let's, as usual, let's go step by step. Then let's return 13. And once we have this for each bank, we'll eventually add them into a result. But so total output voltage, but we can call total voltage, okay? And it will start from 0, and we will increase it by max voltage from each bank, and then we will print the total voltage in the end, which will be right now this much, because it corresponds to having max voltage of 13 from 200 banks, and 200 banks 200 times 13 corresponds to this value. So we're all good, I think. So basically, I won't touch anything about here, all right? Nothing here. I will just modify here. Given a string, what's the way of finding the two-digit number from there? That is the biggest one. I have an idea. I can traverse the whole batteries in the bank, and I can remember the maximum one, right? and I can remember which index it was, right? I will traverse all the line. Maybe I can show over the example here, for example. Maybe this makes more sense to work on. So basically, I'm pointing at the 2. And then I will say, okay, this is the maximum that I've seen so far. So I will say max value is 2 and the max value index is 0. And then I will check the next one. Is it like bigger than 1? Yeah, okay, let's update it. It's 3 and its index is 1. Oh, I see 4. Okay, let's update it again. And it will go on like this. 2, it's smaller, so we're skipping that. This one we skip. For 4, it's actually equals to, so I don't need to change the max value index, because if I change this thing again, I might lose the big values coming from here, right? It's in our best interest to get the biggest, get the first value here, to have many more options for the second one. So this one will go like this, and until here, we'll go on like without a problem. But here we'll see we'll need to change the max value to 7, and then max index to whatever it is. It's the 9th one, right? Its index is 8. But here we can also go through here, but it's not a good idea. The reason being is, if you choose this one as the first battery, you will skip the next one, right? You basically need to select 2 digits. So you must go through the bank, which is like a certain size. We know that it's like 100, and you have to start from the 0th index, and you should end latest in the 98th, the index 98. All right, basically 99th, which is the latest index, you shouldn't lose. Check this way. You check the maximum value for the first battery, and then from there on you can do another loop. You can iterate with the same logic, but you will not start from this first value, but you'll start from the point that you've identified so far. So here we selected, what happened? We selected here. So as a result, our new check will start from the next one, which is this one, right? And here on we can go from the start to the end, basically. But if you get what I mean, basically I also can do a bit more modularization here. Basically, I have to state that I'm looking, for the first time, I'm looking from the 0 to the second latest string, and I'm going to give this indices to it, and I will ask, give me the max value here. Max value and the index of it, okay? So get max value and index, and you basically give the start with 0 and end in len bank, that's -1, right? It's actually like this will be 99, but we don't want it. We want it. Maybe we can, yeah. Let's make it inclusive, please. It makes more sense. So it will be 0 to 98. Okay, it will be inclusive, and we will get the max value and max value index, and from there on, what we'll do is like max value. I think we can call it max value first, or like digit 1, or like first digit max value. Yeah, I think so. It's a bit long. I don't like it, but it's okay. And then basically you'll have the second digit max value, and you don't need to index of it, the other one, right? You max value of that is enough. So you'll also call the same thing again, but your start will now start from the first digit max value index plus one, and it will end at the here, right? Inclusive. And then once you have that, um, imagine they are like returning a string. Okay, let's call it's returning a string. um, we'll we'll basically concatenate both of them, and so first digit max value plus second digit max value, and then it will cast it to integer and it will return it. All right. um, so I think so far so good. I would like to implement this here actually, if you don't mind. The reason being is I don't want to pass bank variable into this values. It will stay as here, and this inner method will be able to access to it. Alright, so here we had the start and end indices, right? And it will return a string, as we said. Sorry, it will return a string and an integer. Alright, it will return a tuple basically of string in the first part, and second is the integer. And as I said, it will start from it's basically a battery, right? For battery in oh wait, but I think it's for index. I think for index in range, it would be a better one. For index in range, start to end plus one, which is inclusive, right? The end is inclusive. We're going through it, and we're updating max value and max value index here, and they will start from none to none if you like, or we can make it bank 0, and its index could be 0. Yeah, and then it's not a good idea actually. Now I noticed it should start from the start and start, and then you can directly start from the next one. I guess so. Yeah. And all right, so you're starting from the 1 point, the next battery coming from the start location. So battery is here in this case bank I, right? And then you're checking if battery is bigger than the max value, right? It's time to update it with the battery value, and the max val index will be the I. Yeah, so far so good. Otherwise, we'll just going on and on and on, and in the end, you like to return. Here it's a bit. The problem here is actually the following thing. This is battery is like an integer thing, right? We have to make it an integer. So it should also be an integer, because value for here we are storing it as it is, but once we want to return it back, we'll typecast it to string again. So here we'd like to typecast it to string, and then the index will eventually be like this. Yeah, I think so. It looks good, but let's see. It works fine. Interestingly, um, should I go ahead and do it? I feel like we had the get bangs, we have calculate max voltage, and it returns an integer, right? First, we have the total voltage from zero. We get the bangs. We tested it. It looks fine, right? We're testing the individual blocks right now, and for each bang, we are calculating the max voltage, and we're increasing it. If you like, we can also test it right now. The following, we can calculate max voltage of a sample bank that we have here, which was this one, right? Let's see what it will return here. Sorry, it's a function call. So very important, you have to print it as well. It's 78. We can test it with this as well. 92. That is correct. So I think probably what we've done right now is the correct solution. So I would like to go ahead and give this answer. All right, that's the right answer. That's good. But I gotta go now, right at the edge of our timing. I hope this was clear, but let me show you the whole code. Basically, it's this, right? Yeah, actually, this is it. 35 lines of it. This is where the code starts. We have two utility methods, get banks, basically reading the input txt, and calculate max voltage is basically processing each bank, basically each line in this input txt. And here we go. It's if I were to mention about the complexity of things, if you like to think about that, it's we're eventually going over each line, and we're eventually going over each battery on each line, basically each digit on each line, right? So we go through this line twice, but that's okay, complexity wise, right? If we were to have n banks and each bank consists of m batteries, the complexity is inevitably be n times m, because on each bank you will go through m. So if you go through it for the other ones as well, the time complexity will be O(n) times m. The space complexity is so here for the space complexity, yes, I'm reading something from the file and putting into our memory. But I think that's okay. I don't see any other. I think that should be okay. So you're processing something and you ideally want to put it into a storage that you can access it fast, right? So I think that's okay. And then calculate max voltage doesn't really do any big storage. It just has these variables 1, 2, 3, 4, 5, and this one 6, right? So, and these things are probably not creating any additional complexity. So, the space complexity wise, it's like O(1), it should be. But yeah, so far, I will end it here. As I said, I'll be able to catch up the the latest questions over the weekend, it's a bit difficult to do within the week when you're working full time. Thank you, and see you in the next one.